the JD also includes Spark, and they were preferring majority as Scala as a programming language.
Yes, sir.
Some people, 10% of things will prefer Java, and the other 10% of the products prefer Python.
Yes, sir.
Maybe 1 or 2%, very rare. Not even I haven't seen any JD with Spark and R language in combination as of now. But in future we may have this type of scenario as well. So we can say around 80% of the Spark implementations are being done in Scala, and 10% in Java, 10% in Python. Maybe the Python and R can have the 10%, 1% here and 8% here, like that.
Okay.
So as the thing here is, we go with Spark and Scala as a programming language,
Yes, sir.
right? So
Yes.
here we are starting with understanding the requirements, why we need to implement Spark. When already in our project Hadoop is there, when we have a Hadoop clean implementation, why again people are talking about including Spark into the projects? That is a question which we need to answer. So when this is the question, we can take n number of industry standard use cases which have proved tremendous improvement in the performance when they started using Spark in place of traditional Hadoop based MapReduce engines. So in one of the cases Toyota. So Toyota is having very large customer base. Everybody knows it's almost a motor giant, manufacturing giant throughout the country. So when it comes to acquiring the data, Toyota is having almost 700 millions of data points it is getting every day. So it is having various sources like it is having social media, and it is having the survey data. Also, it is having call center information spread across the globe. So when it is accumulating 700 million records every day, process these 700 million, when they are executing this as a MapReduce job, it is taking almost 160 hours. So it is very tedious. So they cannot wait for 160 hours, is more than a week, just for the sake of completing 700 million records. Too much. So what they have decided, let us go with the much optimized and much powerful engine than the traditional MapReduce engine, and they have included Spark, and they have rewritten all their code in Scala on Spark. So the same job, now it is taking almost 4 hours. So which has taken 160 hours, now the same thing is taking just in 4 hours.
Yes, sir.
So that is almost 90% of the time has been saved when they have included Spark in place of traditional MapReduce. The same thing with Uber as well. So Uber also does the world's busiest GPS-based cab service company. We know it, and every minute and every second it has to do all these 3 calculations. It has to calculate the surge pricing, and it has to help to avoid accidents, and it will help the drivers to place a car in a position where they will get maximum rides. So every second it has to calculate this information, and it has to publish this information for the drivers on the dashboards. So up to 2014, they have a different architecture based on Circa. But after 2014, they have realized the importance of Hadoop, and on top of Hadoop, they have Spark for faster processing, and they have changed their architecture, and you can see it on the right hand side. So like that, if we can go with the use cases, we have a number of use cases from the topmost players in this domain, which helps us to understand the importance of Spark. So keeping all these examples in a nutshell, we can say like this. So whether it is a healthcare domain industry, or whether it is a media-based industry, or finance industry, or retail or travel, not only limited to all these 5, even for other industries, they have slowly migrating into Spark on top of Hadoop. So they don't maintain 2 separate infrastructures, one for Hadoop and one for Spark. Always what the companies will do, in the same infrastructure, whatever they have, the Hadoop infrastructure, on top of the Hadoop infrastructure, they will maintain the Spark infrastructure. So that's how it helps in minimizing the cost of the resources in terms of infrastructure and other stuff. And of course, this slide is only speaks about the top companies which are having Spark requirement in this, last Friday, up to last Friday. And of course, this is well much proved. I just hit the Spark and Hadoop requirements, and in the top, CMM level 5 and the top 100 companies, then these are the listings. And
So one small doubt: what is that number in the bracket, sir?
number of openings, having 21 openings, and UHG is having 11 openings, Accenture 10, like that. These are the number of openings for resources who having Spark as a skill set. Apart from okay.
Hello.
Yeah.
Sir, I'm sorry. Your voice got cut, sir.
Okay. So these number signifies the number of openings they have. So 21,
Okay.
yeah, this company is having 21 openings for Spark resources, like that.
Okay. Yes, sir.
So Spark, as we know, Hadoop was launched in 2006, basically. Launched in the sense, Yahoo has donated Hadoop to Apache Foundation in the year 2006. And then they have released their first public version in the same year, but it is around 0.4. It's a very at the starting. Now the Hadoop was in the latest version 2.7, which is a standard and stable version, and maybe by the beginning of the first quarter or end of the first quarter, they are going to release the next version of Hadoop called Hadoop 3.0. Okay, so but if you see the Spark was launched in the way back in 2009. That too as a research project in the UC Berkeley. And after that they have given the same thing to Apache Foundation, and Apache from then onwards, the Spark has become the top level project after Hadoop for the Apache Foundation.
Yes, sir.
And as I have mentioned, Apache Spark cluster computing can be used on top of an existing storage. Also, it is having a language support. We can use Java, we can use Scala, Python, and now with the recent versions of Spark, they're also supporting R as well. And also, it is easily integrated with the Hadoop and the ecosystem for reading existing data from the Hadoop cluster. That is another advantage of it. So I have done a small, testing in my setup. I have taken a 1.56 GB and I have run a PowerCount application using MapReduce and using Spark in my environment. So when I have taken the same file with the same size, for the MapReduce it has taken almost 11 minutes and 1 second. And the same job, when we are trying to execute using the Spark, it has just taken 2.6. Okay, so this is a experience of our own execution when we are doing the same thing using MapReduce and using the Spark.
Yes, sir. So one small doubt. So, like in Hadoop, we don't have much of coding, right? Like even MapReduce is written in Java, but in Hive and others, that also is automated. I just wanted to know in Spark, what exactly do we use the coding language for, like Scala, uh, Java, and all these, Python?
Okay, it's a good question. So we'll see. Okay, the next basically in Spark we have to create our data in the form of an RDB. So when we are creating any data, you have to create your data in the form of what? Either RDD or a data frame. So for creating of RDD and creation of data frames, we have to use the language.
Okay.
Okay. And then we will do some, there are two things where we do it. The first one is called transformation and the second one is called action. So we can do some transformations on the RDDs and we can do some actions on the RDDs. So for that also we are going to use the Scala.
Okay.
Okay. So whatever we do, Spark is not a like Hadoop. Let me explain you. You will understand. I'm about to tell you that. Uh, so you have your Hadoop setup basically. So in Hadoop, what is the storage where you will store the data?
HDFS.
In HDFS. Okay. So to process the data on HDFS, Hadoop does not have any language. So either you have to use directly Java for writing the MapReduce, right? Or you can use Hive, or you can use Pig, right?
Yes, sir.
Whatever you write, it will be converted into a MapReduce application.
Yes, sir.
And that will be using the yarn and that traditional thing, you know it. Similarly, in Spark, you have your existing Hadoop setup, Hadoop infrastructure. When we have a Hadoop infrastructure, on top of that, what you will going to have? HDFS again.
HDFS.
On top of that, we will have the Spark. Okay. So when we
Yes,
have
sir.
Spark, you have to load the data from HDFS into the Spark environment. You have to, if you are getting the data, you have to convert the data from one format into another format, right?
Yes, sir.
That is called processing. So this processing, loading the data from HDFS, and sometimes not only from HDFS, you will also have to load the data from streaming sources, like from sensor, or you have to from any server logs, okay, or from any other ecosystems where we need to load the data into Spark. And then once you process it, again you have to store the data into, get the data or store the data from Hive. Okay. So there are many scenarios. You have to load the data, you have to save the data, and you have to do some data. For all these purposes, we are going to use Scala as a programming language here.
Yes, sir.
Okay. So
Yes,
in Hive, in your Hadoop, you have different languages for different purpose. You have Pig for pre-processing. You have Hive for SQL based processing and like Java for traditional processing. But on Spark, you can do all these things using a single language.
Scala.
Yeah. So in this, we are using Scala API.
Okay, sir. So, even in Spark, it is converted into a MapReduce job, or MapReduce
No,
or not?
no,
Okay.
we don't use MapReduce. Okay, so let me show you. Uh, we don't, we never use MapReduce here. So
Okay.
inside that, this is the traditional, this is our iterative based MapReduce processing in Hadoop base. So here, what it is going to do, all the data is coming from your HDFS into the map, and map will be doing some operations and the data will go into the Reduce. So
Yes, sir.
where the IO is happening, the entire IO is happening on HDFS, right?
Yes, sir.
So HDFS is something like a secondary storage device, SSD. The hard disk
Okay.
is your HDFS. How much of hard disk you have on a data node, that much of HDFS space it can accommodate.
Yes, sir.
Okay, so the IO operations of MapReduce are mainly based upon the secondary storage, and that too on HDFS. And if you configure Spark, what is happening? The first load is coming from HDFS or any other stable storage system. It can be HDFS, Hadoop Distributed File System, or it can be LFS, local file system of the Linux.
Mm-hmm.
Only the first load is coming from this HDFS or LFS. After that, the first iteration is executing and the data is going into distributed memory. Okay, this is like your RAM.
Okay.
So in the previous scenario, all the intermediate outputs are going into HDFS, but in the Spark, all the intermediate outputs are going into the distributed memory. That is nothing but RAM. And again, the iteration 2 takes the data from the RAM and again pushes into the RAM. And finally, the final output again, it go into either stable storage of HDFS or LFS.
Yes, sir. But what exactly happens in iteration 1, 2, and 3? I mean, in the iterations, sir.
In the iterations, we will be performing, as I have mentioned earlier, we will be performing what? Either transformations or actions. We
Okay.
don't call them as map and reduce, but in Spark we call them as transformations and actions. Okay? We will see
Yes.
what is a transformation and what is an action.
Yes, sir.
So what we do all about in Spark, we create an RDD or a data frame, and on the RDD and the data frame, what we create, we can apply transformations and actions.
Yes, sir. So RDD, can it be equivalent to something like a, I mean, what is it? Is it like a database you're saying, or RDD is equivalent to?
When you compare with Hive, you can compare RDD as a table.
Okay.
Okay, in Hive you create a table. Only after creation of table you apply all your joins and group by and other stuff, right?
Yes, sir.
So similarly, in Spark, before doing any processing, we have to create RDD or data frame.
Yes, sir. So data frame, what is the difference between RDD and a data frame, sir?
That we will discuss. Okay.
Okay. Okay. Yes.
In Spark, there are so many things. Okay, let us try to understand the core thing of Spark. Then we will can discuss all the other stuff. Okay.
Yes, sir. Sure.
In a simple way, you can say the difference between RDD and data frame is the difference between a CSV file and a Hive table.
Okay.
If you are loading a CSV file into Hive table, now the data is converted into a table. Table is having what structure? A CSV file does not have any structure, right?
Yes, sir.
Similarly, RDD does not have any schema, but whereas the data frame will have a schema.
Okay.
Data
Okay.
frame will have column names and data types, but RDD will contain only data. It does not have any structure.
Okay, sir.
So at the nutshell, that is the difference. So in Spark, the total API of Spark is very huge, a very big API. So it is having API for almost all the different types of when we are doing high kind of processing, when we want to use SQL language and when we want to connect to a databases, process the data and again store the data into a database, it can be Hive or any other database. So for that, Spark is having a API called Spark SQL. And if you want to connect, if you want to do the streaming applications, like we have discussed before, if you want to get the data from some Facebook, or if you want to get the data from server logs and any other, Kafka, whenever you want to get the data from these type of sources, then we are going to use what? Spark Streaming.
Spark Streaming.
The majority of the course, what we deal with, will be covering these two.
Okay.
And there is one more thing called the data science. In the data science, people will use the machine learning library as well as the graph library. Okay. In our course also, I will give you a couple of examples on this machine learning. Okay. But majority of the Spark and Scala, we will be saving Spark Core. There is one more thing called Spark Core. So we will be seeing Spark Core, Spark SQL, Spark Streaming, and some examples in machine learning.
Yes, sir.
So this is the execution flow, basically. So to understand how the execution will happen in the Hadoop, then you can relate it to like how it is happening. Spark. So Hadoop, you know it. We have a data node, right? Data node 1. We have one called data node 2. Data node 3, like that, right? And we will having another thing called as a name node. Yes or no?
Name node. Yes, sir.
Name. Right. So in the name node, you will be having the resource manager. And in the data nodes, you have the node managers, right? Node managers. And in the node manager, it will create an app master, right?
Yes,
app
sir.
master. And in the app master, it will be going to create a container to run the applications.
Yes, sir.
So you have the app master, and for every application, the app master will be creating the container.
Yes, sir.
Container. So the application first comes to the node manager. Node manager will create the app master, and the app master will be creating the container. In the container, the application will be executing in coordination with the resource manager, right?
Yes, sir.
So in Spark, the scenario is like this. In Spark, whatever program which we are writing, that program we will call it as a driver program. The Spark application, which is having the main method, is called as a driver program. So this is your like your Eclipse or your environment. This is your cluster, Spark cluster. So inside the Spark cluster, we don't call them as data nodes, but we call them as worker nodes.
Okay.
Okay?
Yes, sir.
Worker nodes. And the request, like in Hadoop, the request first of all goes to the cluster manager. And what is the cluster manager in Hadoop?
Name node. Oh, Yarn. Okay. Yeah.
Yarn. Okay. Yarn will be having the resource manager and the node manager. Both are belonging to the components of Yarn.
Yes, sir.
Okay. So similarly, when we are writing your program, your Spark application, and first of all, you need to contact the cluster manager. Okay.
Yes, sir.
So how the application is like, because to execute on a Spark cluster, first of all, the application has to speak to the cluster manager. So for that purpose, in all the Spark applications, what we are writing, we have to create a context called Spark context. Okay, technically, try to follow the architecture while creating the programs. You will see how to create a Spark context. But this is
Yes,
the
sir.
architecture you have to follow.
So here
So right
Spark context is a predefined something like a library.
exactly. It's a predefined library. We open that context. When we are opening the context, it will automatically connect to the cluster manager.
Yes, sir. SC dot.
Yeah, SC is already available. For SC, we can specify the futures. We
Yes,
have to mention who is our cluster manager, and there are some other details. Okay,
yes, sir.
we need
Yes,
to mention some details for the before creating the Spark context.
yes,
Okay,
sir.
the process here is there is something called as Spark configuration, Spark conf. First,
Yes,
we
sir.
need to create the Spark configuration. From this, we create the Spark context.
Yes, sir.
Once we have created the Spark context, using this context, you can connect to the Spark cluster.
Yes, sir.
Okay, that is the hierarchy. Okay, so your program, and in your program, you are going to create what? Spark context. And
Spark
this Spark
context.
context will be speaking to the cluster manager, and the cluster manager will be deciding on which worker node your program must execute.
So, sir, you said this is run on top of HDFS, right?
Run on top of, yeah, Hadoop, not
Run
HDFS, on Hadoop.
on top of Hadoop. So
Yeah.
Hadoop will have its own infrastructure still, no, sir. So where does Spark get its information from in Hadoop?
See, it's a good question again. The scenario is like this. So when we have like this, so data node 1, 2, 3 like that, okay? Within the data node, if you install Spark as this layer, so this layer is called Spark. Within the
Okay.
same data node, I have installed the Spark also. Then when it comes to Hadoop, I will call this as a data node, but in terms of Spark, I will call the same node as
Worker node.
okay. In Spark, it is a worker node. For Hadoop, it is a data node.
Okay.
Got it?
Yes, sir.
So within this worker node, what are the resources of the worker node in Spark? In Hadoop, we see container and other stuff. So coming to Spark, we will call that as the executor.
Yes, sir.
Application master, which will execute the application. In Spark, it is called an executor. So executor will be dividing the total application into tasks,
Okay.
number of tasks. It is, and each and every task will be executed in the cache. It will create a cache, like a container, we can say, and in the cache, all the application, all the tasks will be based upon the complexity of the application. Application can have 2 tasks, 3 tasks, or 100 tasks.
Yes, sir. So what is the catch to you said, sir? I'm sorry.
Cache is usually like, cache is the area where your tasks are going to be executed.
Something like a pipeline, sir, where I mean for buffering, like easily it will store the information. So is that why cache is used for even here?
Exactly the same.
Okay. Yeah.
Okay.
Okay.
All the
Yes.
intermediate output and all the IO are happening through the cache.
Okay.
Okay. This is called distributed cache, which we have seen in the previous thing, right?
Yes, sir.
So that is the distributed cache. All the intermediate outputs and whatever you can use it for faster processing, it is doing in the distributed cache.
Yes.
So in Hadoop, when the same thing is happening on the HDFS, but in Spark it is happening through the RAM in the form of a distributed cache. So which
Okay.
is faster, obviously, when we are doing some IO on HDFS, like Hadoop, we are doing the whole thing on HDFS, but in Spark we do all this stuff in RAM.
Yes, sir.
So obviously, doing computation on RAM is much faster than the doing computation on HDFS.
Yes, sir.
So that is the advantage of why Spark is much faster when compared to your traditional Hadoop-based implementation.
Yes, sir.
Okay, so we call it as a terminology where once we have developed the program, like you have seen, right? When you are writing some program using Java, the word count and other examples, you have to create them into a jar file, right?
Yes, sir.
Similarly, in Scala, in Spark also, when we are writing some applications, we have to convert them again into a jar file, Scala jar.
Okay.
So that jar file, we'll call it as a application jar.
Yes, sir.
And the program which is having the main function is called as a driver program.
Yes, sir.
And the cluster manager, we know it is a yarn.
What is Mesos, sir? Yarn. Okay, I understand.
So here you have Spark. There are multiple distributions for the Spark. One is Spark on top of Hadoop. Okay. And the
Yes.
other one is Spark standalone.
Okay. Okay,
Standalone
okay.
using
It will
Hadoop.
work on its own. Correct, correct. Okay.
Then if the Spark is running on top of Hadoop, it will use yarn as a cluster manager.
Okay, okay, okay.
When it is not using Hadoop, when we have configured only Spark on a group of systems, then we have to configure Apache Mesos. Mesos is the cluster manager,
Yes, sir.
standalone mode. Okay, so that is the meaning.
Yes, sir.
So the worker node is a node that application executes. That is a worker node, like a data node. And executor is a process launched in the worker node, which will be taking up the data and runs the application. And task is a unit of work, you know it. And a job contains multiple tasks. Like job is an application, so a job contains multiple tasks. That hierarchy, we know it. So a job can have multiple tasks, like that. Based upon the complexity of the job, we can have multiple tasks.
Yes, sir.
And Spark context means what? Represents the connection to the Spark cluster. So using this context, we are able to connect our application to the Spark cluster. So these are the terminology which we need to understand when we are working for Spark.
Yes.
Okay, so in Hadoop ecosystem, we use a different terminology. But whereas in the Spark ecosystem, we use a different terminology. So the terminology, we need to just understand the basic differences. That is enough.
Yes.
So when we have the whole thing coming in and you have your HDFS and there is a file and this is your Spark and you have loaded this file here. So when you are loaded the file here, the file will be converted into what?
RDD.
RDD. Okay, and whatever, anything you are storing or you are getting it into the Spark, it is nothing but a RDD. So we need to understand what is this RDD. So RDD, it stands for Resilient Distributed Data Set.
Yes, sir.
So what is this Resilient Distributed Data Set? Resilient Distributed, RDD. I will take this example. It flows better light. Understanding this part. So in this example, what I'm doing, there is a big table, and our file, a big CSV file, and I'm loading this file into the Spark. So obviously, it is nothing but my RDD, right?
Yes, sir.
So the file is so big that the data is available in the form of partitions in the RDD. Like the file is having, for example, for our understanding purpose, okay, the file is having 100 records. What I will do, I will create 4 partitions. Each and every partition contains how many? 25.
Okay.
Okay. While creating the RDD itself, I will create an RDD with 4 partitions. So we can create RDDs with partitions. Okay.
Yes, sir.
So why we use partitioning concept here? Just to distribute the data, because Spark is a distributed environment, right? Like Hadoop.
Yes, sir. So,
Hadoop,
is it
yes.
distributed in in order, so like the first 25 records, or is it distributed randomly?
No. It will distribute by range.
Okay.
Default, it will do the range partitioning. Range partitioning means it will distribute first 100, next 100 like that.
Okay.
Okay. So
And if
uh,
a record is required,
yes.
where is the
Hello, Abhijit.
uh,
Abhijit, the last voice. Hello? Abhijit?
hello?
Yeah, Abhijit. Yeah, I can hear you. Yes. Yeah, Abhijit.
Hello. So can you hear now?
Yeah.
Yes, sir.
Some question. Yeah, please go ahead.
Yeah, so I just wanted to know, if it is partitioned, where is the metadata stored? Like, how does Spark know which file to go and take the information from? Which partition to go and take the information from?
Okay, it's a very good question again. Spark will be maintaining the lineage. Okay.
Okay.
This we yes, okay. After the RDD lineage, remember it.
Okay.
Okay. Every RDD and everything will be maintained in the form of the lineage. Okay.
Okay.
For example, partitioning is something like a splitting. In Hadoop, you will be splitting the data, right? Block size,
Yes,
128.
yes, sir. Yes, sir.
The RDD is partitioned. So here we can take it as a block. One block is nothing but one partition.
Yes, sir.
Okay, that is this type of concept. And all the partitions can be saved in different worker nodes.
Yes, sir.
So it's not like that all the partitions saved in a worker node, same partition, but based upon it, like you can see in this example, partition 1 is coming here and partition 2 is going here and 3, 4 are coming like this. So different partitions can be saved on different worker nodes, and they will be processed by the executors on the worker nodes.
Yes.
So it is distributed. The storage is distributed, and also the processing is also distributed, like Hadoop.
Yes, sir.
Okay. So what in physically how the RDD looks like? This is how the RDD looks like. So in RDD, you have a piece of data, very big data, and we are storing the data into an RDD. First of all, what it will do, it will create the partitions. So it will create partition 1, and it will create partition 2, and it will create partition 3, like that. And it will create one more array like this. So inside this, what it will save? It will save the references of the partitions. Okay? References means address. So this is our RDD. So what RDD contains? References to the Abhijit. Okay. Yeah. So please let me know. Hear me. Okay. So what RDD contains? RDD contains the references to the partitions.
Yes.
So wherever data gets stored, data will be there in the partition. But
Yes,
the
sir.
RDD is not reference to those partitions, and these partitions are all in the distributed cache, right? So one partition can be executed by one executor, and E1, and this partition can be executed by another executor E2, and it can be executed by again E1. So the execution are also distributed.
Yes, sir.
So when we relate this guy here, like this, when we have different executors, I can, if I have a RDD with some more partitioning, then
Hello.
yes. So I can have a partition
Okay.
which can be executed here, and the same for the same RDD, the partition P2 can be executed by here, like that. Like how your data will get processed. You are not sure in which data node all your data get processed. The data may get processed in different data nodes, right?
Yes, sir.
Okay. So Abhijit, so far what we have discussed, let me put it across here.
Yes, sir.
Yeah, okay, from the pictures it seemed like a short girl. Yeah, I know this is.
Okay, so we have seen Spark introduction, and we have seen something on the context and the technology, and we have seen something on the RDD. Okay,
Yes,
so
sir.
far. So RDD is something like you have asked how the whole thing will happen and how it can, where the information gets stored. So the entire information of the RDD will be available in the form of a lineage diagram.
Okay.
Oh, Kaylee,
Okay. So in the lineage diagram, what it is going to do, is going to maintain the state of every RDD. Like for example, in the next slides we are going to discuss probably tomorrow, like how we are going to apply the actions and transformations. What will happen once we apply a transformation and what will happen once we apply a action on the RDD. So all these things, the RDD will be saving it in the form of what? A lineage.
Yes.
Understood?
Yes. Hello.
Okay, is it fine now?
Yes, sir. It's fine.
So that is how the whole thing will, so in the lineage, like in the RDD, once you have created the RDDs, you will be applying two things. One is the transformation, the other one is the action. So transformation means what? It's changing the RDD into a different format. Like for example, you have a RDD like this, and from this RDD you are creating one more RDD in this format. And from this you are creating one more RDD in a different format. Okay, so you are having a RDD1 and you are taking RDD1, you are converting into RDD2. And RDD2 you are converting again into RDD3. Like, you know, in Hive you can remember this as loading the data from one table into another table. Take one table, join these two tables, create one more table, and do some calculation, create one more table. So every time when we are applying the transformation, RDD, if we are applying transformation to an RDD, again you are going to get one more RDD. Okay?
Yes, sir.
And when we apply the action, action is nothing but the final result, what we are expecting. So when we apply an action on the RDD, you are not going to get one more RDD, but you are getting what? The final output. Okay. So here what we need to remember, when we are applying the transformations, you will get RDDs. When you are applying action, you will get the result.
So the transformation also is done in Scala only.
Exactly. Transformation, action, both we are
Both
doing
action anywhere, transformation also in Scala. Okay, okay, yes.
Exactly. Okay, so this process is called lineage. So lineage tells about how the RDDs are converted into one RDD and another RDD. For example, you have taken RDD1 and you have applied some action, transformation on it. Okay, transformation 1, and it has given RDD2. And RDD2 you have applied one more transformation 2, and it has given RDD3. And on that you have applied the action, it has given the output. So this is called the lineage. So in the lineage is nothing but a direct acyclic graph, DAG. Okay. So in that lineage, your Spark is going to maintain this information, this DAG information. So it will create a graph out of it and it will maintain the scope of the RDD. So R1 is converted into R2 and again R3. After that, the result like this. It will maintain a graph of it.
Okay.
Okay, so what is the use of this graph? It proves that, you know, how exactly this RDD is generated. Due to some failures, okay, failure is a common thing, which we know it, right? So due to some failures, an RDD can be lost.
Yes,
right?
sir.
An RDD can be lost. So when the RDD is lost, you have to regenerate the RDD, right? In Hadoop, you have the concept of replication, right?
Yes,
So
sir. Yes.
three replicas. If you lose one block, still you can have 2 replications.
Yes, sir.
But in Spark, we don't prefer the concept of replications because Spark will be running on memory. Memory is very costly.
Yes,
Memory is very costly. If I have one RDD, if I want to maintain 2 more RDDs, it is very costly operation. So
Yes,
I don't want to maintain the extra copy of the RDD. So what I want to do, I want to create an RDD and I want to maintain the lineage. So R1 is there, which is taking the input from some file, and out of this we have generated R2, from R2 we have generated R3. If this is the lineage, all of a sudden, if my R3 is lost, okay, so if my R3 is lost, what I can do, I can apply this lineage operation. In the lineage, it's mentioned that you can take R2, and R2, if you apply this transformation called T2, you will get R3. This information is available in lineage, right? So
Okay.
whenever I lost R3, I will speak to the lineage, and lineage informs me how the R3 is generated. Again, I will apply the same T2 on R2, again I will get R3.
Yes, sir. So you mean to say it can have multiple R2 can become R3 using T2 simultaneously if you create something using say another R4 using T3.
It's also
Okay, that
possible.
counts. Okay, okay. Yes, sir. I got the point. But another doubt, so T2
Yeah.
can be applied only to R2 to get R3. You cannot reuse transformation like T2 cannot be used between R1 and R2 or, I mean,
That
for R1.
exactly. It's correct.
Okay. Hello.
Hello. So what we can do, Abhijit, just we are running and I have follow-up sessions as well now.
Okay.
Okay. So just whatever you have done, just try to revise it. Okay. In the next session, I will show you like how the things will happen. Like we will check with your Cloudera distribution and which version of Spark you're using. And if you're using some lower versions, and we will see how we can get the latest version. Okay.
Yes, sir.
And yes, yeah,
So
you have.
and Cloudera will have I mean by default it has Scala also. Or you have to download Scala, sir.
It will be having Scala, but we need to use some Eclipse IDE. That I will show you. Okay. For
Yes, sir.
execution,
Yes.
it is having Scala, but for us to write some programs in Eclipse, we need to download the Scala IDE and we need to configure it. Okay.
Yes, sir.
That problem we can see it. Initially, we don't require when we are dealing with Spark. When we are first of all, once the interaction is done, we don't go straight away into Spark. First, we will see the Scala as a language.
Yes,
How
sir.
to create different things in Scala and how to create functions and objects in Scala. So for that,
Yes,
we
sir.
need Scala IDE's help. That we can configure it. Okay.
Yes, sir.
Abhijit. Yeah. Take care and good night. See you
Okay,
again
sir.
in.
Okay, sir. Thank you, sir. Thank you so much.
Bye. Good night.
Yeah.